All right, section 3.2, part A, looking at the remainder theorem. We use the remainder theorem to basically divide a binomial of the form x minus a into any polynomial expression. Okay, so we're dividing polynomials here. But before we jump into that, we're going to review how we use long division. So we want to go back to our elementary days, and before we had calculators, and let's say we gave the value 6,540 and we wanted to divide that number by 6. In order to do that, we used the skill of long division, and we took 6 and we're going to divide it into 6,540. So how do we go about this process of long division? Our first step is we take this outside value. How many times can it divide into this first value? Well, 6 can divide into 6 one time. So I'd put 1 above my 6, and then we come back and multiply that value. So I'm going to come back and multiply. 1 times 6 would give me 6, and then I would place this underneath this same place value. And then we want to subtract these values, which would be 0. At this point, we are now going to bring down the next number, 5. So then we ask ourselves, well, how many times can 6 divide into 5? Well, it can't. So that would go 0 times. So if it can't divide into this next number, then we have to bring down our next value to include the number 54. How many times can 6 divide into 54? That should be 9 times. Come back and multiply. 9 times 6 is 54. We subtract these values again to give our value of 0. And then we bring down this last place value of 0. How many times can 6 divide into 0? And my answer would just be 0. So how many times can 6 divide into 640? The answer would be 1,090. Okay. You will come across a division statement where this denominator doesn't actually divide into the numerator evenly, which happens here. So we're going to do the same thing. We're going to take 4 and we're going to divide it into 1,751. So in this case, 4 cannot divide into 7. So rather than necessarily putting a 0 there, now I'm just going to go to the next value. 4 can divide into 17 4 times. So then I'm going to come back and multiply. 4 times 4 would give me 16. So 4 can go into 17 4 times, but it's not going to divide into the number evenly, like what happened over here. So I come back and multiply 16. I'm going to subtract these values, which gives me 1. Now I'm going to bring down my next place value, which is a 5. And then I'm going to divide 4 into 15. Well, 4 into 15 doesn't go evenly, but it can go into it 3 times. 3 times 4 would be 12. Gives me 3. I'm then going to bring down the 1. And then divide 4 into 31. Well, 4 divides into 31 7 times. 7 times 4 is 28. Subtract these values and have 3 left over. So because there's no place values left over, this is our endpoint. So how many times does 4 divide into 1,751? It divides into it 437 times. With a remainder, we're going to go back to our elementary school days and talk about remainders. So this has a remainder of 3. So rather than finding this as a decimal value, we're going to give it a whole number value, 437, with a remainder. So what's remaining? Follow somewhat of the same process when dividing a polynomial by a binomial. So I want to take an x plus 1 and divide it into this polynomial. So how do I do that? So I'm going to take x plus 1 outside, and I'm going to set up this long division just like I did up top. So I'm going to divide it into x cubed plus a 2x squared plus 3x plus 2. Okay? So in order to divide a binomial into a polynomial, we really just want to focus on this outside term and divide it into the first term of the polynomial. And then time, this extra value will kind of work its way out. So how many times can x divide into an x cubed while it could divide into an x squared times? So when you write your values, I want to line up your place values, basically. X cubes, x squareds, x's, and then your constant. So just like we did up here, we're going to come back and multiply this by the entire binomial now. X squared times x is an x cubed. X squared times 1 is a plus x squared. And what should happen is that this first term should always, and then your next step would be dealing with your x squared place value. So now I'm going to subtract this just like I did up here, but I'm subtracting both of these values. So x cubed is nothing. 2x squared minus 1x squared would leave me with an x squared. And then I'm going to bring down my next place value, just like I did previously. So now I'm going to ask myself, well, how can x divide into x squared? And that would go in x times. So at my x value above my x placeholder, come back and multiply. X times x is x squared. X times 1 is 1x. I'm going to subtract these values. Those cancel. 3x minus 1x would leave me with 2x's. I am now going to bring down my last place value, which is a plus 2. And then I'm going to ask myself again, how many times does x divide into 2x? Well, that would be 2 times. Come back and multiply. 2 times x is 2x. 2 times 2 is plus 2. Subtract these values. Those cancel. These also cancel. So we end up with the remainder of 0. So x plus 1 actually divides into this polynomial evenly, because there's no remainder, x squared plus x plus 2 times. Okay, so this would be my solution. Okay. All right, so let's try another one here. X cubed plus 5x minus 18 divided by an x minus 2. So I'm going to set up this long division. Okay, when I go to write this long division, because there is no x squared value in my polynomial, but I am going to get an x squared as a placeholder in my solution, I'm just going to include that place value by putting a 0x squared there, just so it's easier to line up all of my place values. Okay, again, we're going to start by dividing x into x cubed, which goes x squared. Come back and multiply. We get an x cubed minus 2x squared. We're going to, so my x cubes are going to cancel. 0 minus a negative 2x squared becomes a positive. I am then going to bring down my 5x. Divide x into 2x squareds, which would go 2x times. Come back and multiply. We get a 2x squared minus 4x. We're going to subtract. Our first values cancel. 5x minus a negative 4x changes that to a positive, so we get a positive 9x. And lastly, we're going to bring it down our last place value of minus 18. X divides into 9x 9 times. Come back and multiply. Subtract. And again, we end up with a remainder of 0. So the solution of x minus 2, the polynomial x cubed plus 5x minus 18, would be x squared plus 2x plus 9. All right. So when we talk about dividing into a polynomial, we use like correct mathematical terms or the ways we want it as our answer. So the result of a polynomial in x, p of x, and we say p of x is our polynomial, by a binomial of the form x minus a, where a belongs to the integer, so a is a whole integer value. We say p of x is the polynomial divided by our binomial should equal q of x, which is our quotient, so this is our quotient, plus whatever the remainder is divided by our binomial. So technically for this expression to equate to our answer, the polynomial divided by our binomial quotient plus the remainder over the binomial that we're dividing by. Okay, p of x is our polynomial. So these are the notations you're going to see. P of x is polynomial, q of x is our quotient, capital R represents the remainder. The degree of the divisor must not be greater than the degree of the polynomial. Okay? So you can never divide, let's say, an x to the fourth into an x cubed. You'll never be asked that question. Okay? The degree of the remainder must be less than the degree of the divisor. Okay? So the remainder will always be less than whatever your binomial is. Okay, so let's divide quickly, and then we'll talk about our solution as an expression like above. So we have x minus 2 divided into 2x cubed plus x squared minus 13x plus 9. X goes into 2x cubes, 2x squared times, right? We're going to come back and multiply. We get 2x cubed minus 4x squared. We're going to subtract. X squared, those cancel. X squared minus a negative 4x squared is a 5x squared. We're then going to bring down the negative 13x. X goes into 5x squareds. 5x times. Come back and multiply. We're going to subtract these values. We end up with a negative 3x. Down the 9. X goes into negative 3x, negative 3 times. Come back and multiply. Subtract. Those cancel. And we end up with a remainder of 3. So the binomial actually doesn't divide into the polynomial evenly. Okay? So we end up with a remainder. So what would our product look like, or our solution look like, as an expression like this, right? So the polynomial, which is 2x cubed plus x squared minus 13x plus 9, were to divide it by x minus 2, that would be an equivalent expression of my quotient, which is 2 plus 5x minus 3, plus my remainder over the binomial I divided by. Okay? And so this is how we'd write our solution in this form. So our quotient is 2x squared plus 5x minus 3, plus our remainder is 3 over the binomial we do. All right, and then finally, example 4. This is a typo. This should not be there, so we'll just void that out. It says, when a third degree polynomial is divided by 3x minus 1, the quotient is x squared plus 2x plus 2, and the remainder is 1. Express the polynomial in the form of ax cubed plus bx squared plus cx plus d. Okay, well, what do I know? From this expression up here, we know that the polynomial, which we don't know at this point, divided by the binomial, which is 3x minus 1. So the polynomial divided by the binomial should be equivalent to the quotient, which is this, x squared plus 2x plus 2, plus the remainder, which is 1, over the binomial we divided by. All right, so how do we take this expression and actually calculate my binomial? right? So how are we going to get our binomial from this? So technically what we have here is we have this expression plus this expression, write this whole expression with the same denominator. So I want to multiply, I want to get a common denominator between these two expressions. So that tells me I need to multiply my quotient by this binomial, and then my entire expression here is going to be over 3x plus 1, which is what we want to end up with. We want an expression of my polynomial over 3x minus 1. So if we do this expression, collect our like terms, that will give us our polynomial. So to expand this, I got to expand my 3x through all of my brackets, and then I got to expand the negative 1 through. So when we do that, we get a 3x cubed plus 6x squared plus 6x minus x squared minus 2x minus 2, and then we have this plus 1 still, all over 3x minus 1. So when we expand all this or collect our like terms, we end up with a polynomial. So p of x is going to equal a 3x cubed plus 5x squared plus 4x minus 1. And this ends up to be the polynomial that it's asking us for. And that is the remainder theorem, part A. We'll get into the second part.